Welcome to the session. Greeting of the day. In today's class, we are going to see about in liquid penetrant testing. We are discussing about the procedures, the equipments, what are the various type of penetrants and the characters. All those things we have discussed. In continuance with that, penetrant is one of the important setup that we needed. Along with it, developer, one of the other spray, we needed to do this dye penetrant inspection. So in the previous classes, we have done regarding liquid penetrant inspection. In continuance with that, we would like to see today about this developer. It plays an important role. It means we have to take back this penetrant which is applied. We have seen such a small indications, likewise the defects and the penetrant getting down, and we have applied the developer here. Without application of the developer, the penetrant will, due to these capillary reactions, it will come back and it will be visible. This is what the procedure, the idea. We are going to see about this developer now in this class. The developer. Its role is to pull the trapped penetrant material out of the defects, spread it out on the surfaces of a part so it can be seen by an inspector. So we are, this is already trapped inside. I am talking about this one. This is called as a penetrant. So this is nothing but a penetrant, this one. This is penetrant and this is developer. So this is the developer I have given. This is the developer. So now, the penetrant is the first step involved in the dye penetrant expression that we are putting inside, and it is trapped down in the cracked surfaces, in the cracked gaps and the cavities. When the developer is applied over there, the trapped penetrant which is inside will be pulled out and it is observed by the developers. And it is very easy visibility we will get in the contrast colors, in such a way we can be able to visualize or inspect by the inspectors. It also provides a light background to increase the contrast when visual penetrant is used. You see, at the surfaces all are in white color because the developer is in white color. So we have sprayed a complete white on the white surfaces. Any contrast, various colors. This penetrant is in red color, maybe any other color contrast colors also we can able to use. And it is at specific point wherever the crack, wherever the discontinuities are there, at those points it is easily at the contrast color visibility increases. That's what the point here. The light background, the white light background increases the contrast to the other colors of red color. The fine developers, particles both reflect and refract the incident ultraviolet light, allowing more of it to interact with the penetrant, causing more efficient fluorescence. Sometimes we will use this ultraviolet rays also to do the inspections. But when we are using the fluorescent penetrant, we will get some brightness. You have seen the watches are all in radiant. So when we are using such radiant fluorescence powders or liquids, this, when we are applying ultraviolet rays, these rays are reflected more as compared to the normal penetrant. The fluorescent penetrant will reflect more and refracts. Therefore, we will get much more brightness there at the specific point. Therefore, it is visibility also increases. So the contrast, and we do the inspections easily as compared to the normal. Both are this is a normal penetrant and this is a fluorescent penetrant. And we can able to do on the developers. Developers also create a white background. So there is a great degree of contrast between the indications and the surroundings of the background. It is the same point which reflects again here. Some characteristics of a good developer I want to discuss. We have already seen, you see in the next slide, I have compared here regarding on the left side, here I have will be the characteristics of good developers, And on this side I have the characteristics of a liquid penetrant. It means the two major components we are using. One is penetrant, and the second one is the developer. So we want to see the characters, how it behaves when it is subjected to the inspection, and when we are going to put on the sample. So it may toxic, it may others, some noise, some smells may come, or it will irritate the skins. So odorless to be there. It should not be harmful to the inspectors or operators who are doing those things, and also to be contrast, should not evaporate quickly. So those things are there. So we will see one by one. With this characters of liquid penetrant, we have already done there when we are doing the penetrant types. Now we will go back to the previous slide that I have elaborately given here. Just for understanding, I have given one slide. Characters of good developer. It should have a good porous to make capillary action. I am calling this a bloating action to absorb the dye penetrant over the developer. You see, we have. So let us assume this is the sample. This is the sample to be inspected, and we have a small crack over there, and we are applying the penetrant over here, and we are applying the developer. In this developer, it should be good and porous. It means it should not be tightly bonded. Atomic freeness to be there. I have taken this only developer part here to draw. So this is, let us assume this is developer, and it may contain some specific atoms. Various atoms will be there with the gaps. It is called as porousness. So what happens? Let me draw here also. See, we have not. It is not a tightly packed one. It is somewhat. It is loosely packed. That is why I am calling this as a porousness. Now what happens? Due to this porousness, the atoms are free, and there is some spaces there where the other atoms can include there. There is nothing but a penetrant atom. Now what happens? The penetrant is going to include over there. So in this gap, the penetrants are included in between. So now it becomes tightly packed. So where it will be? So here the only penetrant is there. Therefore, only the zones where the penetrant is available, this zones only it is filled. Because it is porous, it can able to receive some other atom because it's not fully packed, completely packed one. If it is completely packed, metallurgically it will suffer to get inside the other one. Therefore, the main characters or main properties of the developer to be porous. Therefore, it can receive the other atom inside. So the penetrant atoms is getting into the porous developer. Therefore, it is looking contrast in the color point. So I am calling this as a bloating action. So this capillary action which is taken place from penetrant to the developer, I am calling this as a bloating. To observe the dye penetrant over the developer. So this is what happened. Dye penetrant happened over the developer which is in the good porous in nature. Now the next point. You should have a good absorption characteristics. It is absorbing therefore. As it is porous, it is getting absorbed. You should be chemically inert with the test materials. You should not react. Reaction should not take place. Here I have material. I have made the developer over there. There should be no chemical reactions on the surface. Otherwise, it will corrode something. It will remove the materials. Thickness will reduction. It leads to some other problems. You should be able to uniformly cover the surface with thin, smooth coatings. You should provide a good contrast background for bright and clean indications. This is what a white background, red penetration. That's why it should be good in contrast. It should be non-toxic. It should be easy to remove after inspection. Somewhat the stains are there, very strong stains. When the developer is applied over the specimen, it will stick over the samples and it is not possible to win even when it is water washable clean or solvent clean process is done. The stains of the developer which is fixed over the specimen will not come out. it should be easily free to move. It's easily to be removable. So that's the point. It should be easily to be removable. We should keep in drawer. That is about the characteristics of a good developer. So see, this is what the comparison between the characteristics of a good developer and characteristics of liquid penetrants. So I have compared between two background sites. Now you see, it should be easily over the surfaces. This is all we have already seen. It should have easily drawn into the cracks, getting inside. It should not be harmful to the inspector. Should not be toxic or odorous. It should possess a highly indicating capability, red in color. It should remain in the fluid state. Therefore, if it is in fluid, not in fluid state, it will dry out. It should not dry, then the stain forms on the surface. It should be in fluid state. Then it can easily absorbed by the developer too. Okay. So it should not affect the physical and the chemical properties. It means it should not react with the material. Same reflects there. There also chemical reaction should not take place anyway. Maybe the penetrant, maybe the developer. No reaction should take place. Find it low cost or should happen. Should remain in the defect but remove easily on the surfaces. I am classifying this developer as like we have done for the penetrant, maybe a visible penetrant or maybe a dye penetrant, maybe a emulsified, water soluble, solvent soluble, or otherwise based upon the sensitivity we have divided the penetrant. So out of all like that for penetrant types, I have dividing this developer types also into some 4 categories. Water soluble developers, dry powder developers, water suspensible developers, non-aqueous developers. You see, the name water washable, water soluble, a dry powder, water suspendable developers. It's not dissolving in the water, but it is mixed there. Therefore, the name is water suspendable developers. Then it is non-aqueous. You see. Number 1 I have taken as a water soluble developers. They consist of a group of chemicals. A group of chemicals are already dissolved in the water. So it is a water soluble developer, but this water soluble developer having some chemicals inside it which is already dissolved there. And form the developer layer. So this layer, I am talking about this developer layer. This layer contains the chemicals and it is dissolved and it becomes water soluble. When the water is evaporated away, using the water to make the particular developer. The best method for applying water soluble developer is by spraying it on the part. Dipping or brushing the solution onto a surface is sometimes used, but these methods are less desirable. These methods are somehow it is a less desirable one. You can able to understand this here. This water soluble methodology, how we are doing, these materials will be getting evaporated and the powders will be there. That's why it is water soluble. When it is a dry, hot air is passed over there. Here it is, when I am passing the dry hot air, there. Now what happens? It is already dissolved there. When the hot air is passed, water is going to evaporate, but the dissolved powder, the dissolved chemicals on the water will be staying back there. So that is it came as a solid powder and it is going to absorb the penetrant which is here over there. So it is known as the water soluble developers. Everything is going to evaporate, only powders will be staying back. Out of not only spraying we are doing. So not only spraying we are doing. The number 1 method is spraying. Number 2 method is dipping. And number 3 method is brushing. So in these 3 methods, this water washable or any methods which are in liquid, we can use this. Out of this, spraying is recommended. So out of this, the spray method is recommended here. Because dipping, we have to, more number of liquids are wasted sometimes. We have to put a bathtub and you have to dip inside and you have to take out. Sometimes it may waste. And brushing also, not equally brushed over there. So it will be, we keep on brushing at one point of developer, liquid developer, like painting operations, and maybe coating thickness may vary. So out of this all, uniform thickness also possible, but out of this all, the spraying is mostly recommended. Dry powder we have completed. So water we have completed. Now we are going to see about the dry powder. It is here also. What happens after drying? After drying, it become water went out. Water went out, only powder. Only powder. But here you see, this dry powder only directly applying here. Dry powder developer is generally considered to be less sensitive because we are using a powder and we are throwing on the surfaces, just like that we are, like a normal powder we are throwing on our faces for, likewise we are throwing on the material. So what happens, the developer which is thrown over on the surfaces, it is sticked over there, it's not a fluid to spread. Therefore, equal thickness we will not get. If equal thickness is not there, at some points, let us assume we have a sample now, and I have a powder spread over here, and spread over here a large one. So it is large, slightly reduced, and some irregularities like this. So now, when there is a defect, here, this large powder can absorb more. Here slightly lesser and slightly lesser. Therefore, it is all are in equal crack size. Let us assume all are having equal crack size. But here the powder is higher, but powder is lesser. But powder is very micro level, less, very very less. Therefore, the higher the powder, higher the porousness, higher the absorbing. So this will be more contrast looking. So these are all lightly contrast less looking. So not easy to identify the cracks if it is not equally distributed. So it is less sensitive when it is in the powder form. It is more sensitive to find the crack when it is in the liquid form. So that is why here we have mentioned as it is less sensitive, but it is inexpensive because we are not using water or any soluble method. Some secondary operation we are not doing. Directly purchasing powder and we are using to use, and it is easy to apply. Easy to apply, but we have difficulty in sensitivity there. Dry developers are white or sulfuric powders that can be applied to a thoroughly dry surface in the number of ways. So here also number of ways are there. Maybe spraying like a air spray methods. Advantage is when a dry developer is used, the indications tend to stay bright and sharp since the printhead has a limited amount of room to spread. You see, the powder is only at this point. So what happened? When the powder is only at this point, the spreading of because a fluid it is spread over there, and due to porousness, the printhead comes up, and it is also spread wherever it is in contact with the liquid. When there is a liquid, it comes out and started to spray, and equally until this entire printhead is completed. So entire printhead is completed here. It goes on. But here that is not the case. Here the case is only the powder which you are throwing at a specific point, it only possible to spread over only at these locations. But it is spreading due to its liquid and contacts. But here it is not spreading due to powder non-availability. But it is brighter. Concentration is large at this single point. Concentration is less at this elaborated point. Therefore, higher concentration, higher contrast will get, and good visibility will achieve. So that is what it is having good advantages for dry powder. When water soluble developers are added, it is in wet, and penetrants are easy to spread. Penetrants are easy to spread over the liquid water soluble content. We have seen this on the paper when the wetting happened, it easily spread over there. But the same thing on the solid powder, it will not spread that much, as because it is in dry form. So as possible as it will be absorbed by the specific zone of small limit. Out of this total length, I have a powder here, I have some other powder all over there. Now when the liquid is coming and absorbing here, and the dry powder, most of the liquids are absorbed here only. But at the same condition, on the liquid, it is spreaded. So liquid, we have it is spreaded over there, and when the liquid is absorbed, it may spread here or it may spread here. Comparatively, it is more dry powder having a more denser penetrant at one cumulative point, but here in the liquid water soluble condition, penetrant is spreading over, and therefore density is somehow spreaded. It means therefore room is limited, but here room is high. I'm using the word room where how much it is spraying, how much it is spreading. Maybe this dry powder having some limitations also. Since dry powder developers only stick to the area where the penetrant is present, the dry developer does not provide a uniform white background as the other form of developer do. You see, we have a crack here, and I am spraying, I am putting the dry powder, it is not a fluid to flow over there. I am putting some quantity of dry powder here. I am putting some quantity of dry powder here. I am putting some quantity of dry powder here. I am putting some quantity of dry powder here. I am putting some quantity of dry powder here. The quantity is not uniform all over there. It is a non-uniform pattern. Therefore, since the dry powder developer only stick to the area, it is not a fluid, it is to flow all over commonly and make a uniform line, uniform thickness. So wherever you are putting it is sticking over there itself only. Where penetrant is present, the dry developer does not provide a uniform white background. It means irregular white background is there, and also absorbing. If it is high powder, more red can absorb. If it is less powder, minimum amount of gap only will be there on the bonding. If it is large, means here also it is there. Therefore, more space can be occupied by the liquid. So more powder can occupy more, but uniformity is not there throughout. We don't know how to interrupt those things. So we may be confused for the inspector. As other forms of developers can do in the uniform way. Having a uniform light background is very important for visible inspection to be effective, and since dry developers do not provide one, they are seldom used for the visible inspections. Applications of this dry developers. Dipping a part in a container developers can be done. Using a puffer to dust parts with the developers, or maybe using electrostatic powder spraying guns, right? Or placing a part in the dust cabinet where the developer is blown around and allowed to settle on the part. Any method we can use. Maybe spraying or dipping or dusting, or any putting in the cabinet and allowing to settle down. Any method we can use. So see one photo I have given here. In this photo, it is somehow it is powder is sprayed over there, and the sample is hanged. So this is one type. So any methods we can use for the dry powders. Now we have seen water soluble we have completed, dry powders we have completed. Let me see water suspendable developers. Here it is water soluble. It is chemicals are soluble in the water in the developer. But here it is not soluble. It is sticking over there. It is when you are putting there, it is go to the bottom and stick it there. It should be stirred. Water suspendable developer consists of insoluble developers. See, insoluble developers. You see, there I have shown you first one for water soluble. I have shown you it is dissolved in water. Dissolved in water. But you see now here for this water suspendable, I'm using the word of insoluble developer. Water suspended developer consists of insoluble developers. See, insoluble developers, developer particles suspended in the water. So here the bath. On the bath we have maybe water. On the water I have a particles. It is insoluble. It is insoluble. It means as it is, we are leaving for a while, this all insoluble particles due to maybe gravity, it will come down and settle down here. The density will be higher at the ground. And when we are spraying, only water comes out. Only water comes out, the particles will be down. Therefore, what we have to do, we have to stir and always before application, before applying it on the specimen. Water suspended developers requires a frequent stirring actions, agitations to keep the particles from settling out of the suspensions. So it should not settle out on the bottle, at the bottom. So we have to shake well before it used. Water suspensible developers are applied to parts in the same manner as water soluble developers. So that methodology is the same. We don't bother. So just like a spraying or dipping or painting, that any methods we do as like for the water washable developers. But here the same method is followed, but one method, one additional point I'm using, that I want to frequently stirring action to be done as because it is insoluble. So these are 2 points we should keep remember. So parts coated with the water suspended developers must be force dried, just like the parts coated with the water soluble developers are force dried here also. Right? So here also you see this water suspended developers want to be dried by the air, forced air. Otherwise water will be bottom, therefore it may not be dried. As when the drying takes place, only powder will be there because water is evaporated. So that powder is going to absorb the penetrant. I think we got the point. You see, we have a sample here, right? And then with the liquids I am spraying here. So this liquid contains particles. So liquid also is available there. So liquid also available. When the liquid is evaporated, the particles which is dissolved or which is suspended here will be there because it is a solid particle which is dissolved over there. When the water is not there, the powder will be available as a solid particles there only. So it is filling there. So it is getting down and it is filling these compounds. It is filling. So when it is evaporated, all particles will be fall down and it is makes the layer, solid layer, and therefore the penetrant which is available inside will comes out and absorbed by this developer, this penetrant. So this happens. Maybe therefore it is we need some force drying. Force drying treatment required. Force drying done for both. One is water soluble also force dried, and water suspendable also force dried. So here these two are force dried. These two are force dried. Now non-aqueous developers, the last one we are coming. You see, non-aqueous developers suspended in the developer in the volatile solvent. So the word I am using, volatile solvent, it is a property where having boiling point. When it reaches a specific boiling point, it is automatically evaporated. Right? It will be at a hot sun, it will evaporate. So non-aqueous developers are commonly distributed in aerosol spray cans for portability. It means normally we use this non-aqueous developers. We should not have. We already have 3 components. I have told you this. Already we have 3 components. That is penetrant, right? And then the developer, and then the material. So we have to apply the penetrant first. So penetrant will occupy here. Then we apply the developer second one. It will fill here. It will absorb. In between, pre-cleaning, post-cleanings are there. I am skipping all those things. So here again this penetrant will come there. Now, for this remaining water soluble and this water suspendable, we have to have some other component of drying actions. Dryer should take over there because a forced drying, not normal air, normal ambient drying conditions. It's a dry forced air means we should have a blower there and we should push the hot air. So this is not needed in case of acoustic. This is not needed in case of acoustic because it is a dryer developer itself in the volatile condition. When it is boiling point temperature, it is going to evaporate. Non-aqueous developers are commonly distributed in the aerosol spray cans and portability. The solvent tends to pull penetrant from the indications by solvent actions. This comes out okay from the penetrant. It's coming out. Since the solvent is highly volatile, forced drying is not required. Forced drying is not required as it is going to evaporate automatically. So it becomes volatile. Therefore, forced drying not required. Forced drying not required. So this is a type of non-aqueous one. Totally 4 we have completed. The remaining part of the subjects we'll see you in the next session. Thank you.